You lie back beneath the stars, your breath slowing as the dark unfolds above you. The sky does not shout, yet it says so much. Pinpricks of ancient light scatter across the dome of night, quiet and distant, each one humming with history. You are not alone in your wondering. For thousands of years, eyes like yours have looked upward, hearts full of questions. One star, then another. They shimmer like thoughts drifting at the edge of sleep. You don't know their names, but they feel familiar. Some are hundreds of light years away. Their light began its journey before you were born, before cities rose, before maps were drawn. Yet here they are, reaching you unchanged. Long ago, people thought the stars were holes in the sky, portals to the divine, eyes of gods, or frozen fires nailed in place. But the truth, though quieter, is no less magical. Each star is a sun, and many have planets, worlds you cannot see, but know must be circling, waiting, unseen. You imagine them spinning quietly in their orbits. Some may be rocky, others cloaked in clouds, some basking in warmth, others frozen in eternal twilight. Their suns flicker no brighter than a grain of sand. Yet they hold entire systems in their gravitational arms. The night invites dreams. What if someone somewhere is looking back? In ancient times, the sky told stories. Orion the hunter, Cassiopeia on her throne. But now our stories shift from myth to measurement. We send telescopes into orbit, build observatories in deserts and on mountaintops. We ask our machines to do what our eyes cannot, to listen harder, to reach farther, to find the invisible. These machines, cold and precise, become dreamers in their own way. They capture starlight and parse it like language. Tiny dimming. In a star's glow, could it be a planet crossing in front, like a moth flickering past a lamp? A star's gentle wobble, perhaps a planet's gravity tugging from afar, whispering, "I'm here." This is how we begin to see the unseen, not with color or shape or direct gaze, but with shadows and timing. A dip in brightness, a gravitational nudge, a heartbeat of silence between pulses of light. Our maps of the cosmos grow, not with snapshots, but with echoes and traces. You think of Earth so blue, so full, and wonder how it would look from there. Just another planet, a dot among many. Not central, not even noticeable, but alive. Alive with oceans and trees and breath and minds like yours, looking outward. It humbles you, this reversal. Once the stars circled Earth, now Earth floats quietly. One speck among billions. And yet this does not diminish it. It enlarges everything. If our small planet can bloom with such life, why not others? Why not countless others? The numbers grow dizzying. There are more stars in our galaxy than grains of sand on all Earth's beaches. And beyond this galaxy, trillions more. You picture them not as dots, but as systems, swirls of planets and moons and dust, gardens waiting to be walked, deserts waiting to speak. Astronomers now count exoplanets in the thousands. Each one is a world with its own temperature, gravity, and possibility. Some orbit red dwarfs, dim and long-lived. Some are scorched by heat, spinning so close to their stars they glow. Some are giants made of gas, others small and rocky, like Earth. And some, just some, rest in the quiet zone between too hot and too cold, the Goldilocks zone, where water could flow, clouds could drift, and maybe life could stir. But none of these we have seen with our own eyes. They are silhouettes, patterns, whispers in the light. Still, you feel their presence just out of reach. It's like a dream you almost remember, like a song that plays behind a closed door. To search for exoplanets is to become patient. It is to tune into the subtlest frequencies. Imagine standing miles away from a lighthouse and noticing when a seagull passes in front of the beam. That is the level of delicacy involved. But astronomers do it. And more than that, they trust the math. They believe in what the equations. Say even when the eyes cannot follow, because the sky is a puzzle, ancient and enormous, and every planet we find is one more piece that fits. It's one more confirmation that the universe is not empty, but rich and textured and waiting to be. Known. You drift now, carried by that thought. That we live not at the center of the cosmos, but at the edge of discovery. That to lie beneath the stars is to place yourself in the middle of a great unfolding, where knowledge spreads not like fire, but like light. Quietly and with time. And in this slow unfolding, you begin to feel less alone. Not because you've seen another Earth, but because you know it's possible. It's possibility. The soft light that fills the space between facts. Maybe. Right now, someone on a distant world stands beneath their sky and looks upward. Maybe they see their own stars, feel their own questions rising like mist. Maybe they wonder, too, if they are alone, and maybe, just maybe, they are looking this way. But how do we find these hidden worlds? When they are wrapped in darkness, buried in distance, invisible to even our most powerful lenses. You inhale slowly. There must be a way. You begin to wonder how light itself can carry secrets across time. And maybe, just maybe, they are looking this way. But how do we find these hidden worlds when they are wrapped in darkness, buried? In distance, invisible to even our most powerful lenses. Begin to wonder how light itself can carry secrets across time. Asterisk, you sit at the edge of darkness, watching the stars again. But now you see them differently. It's not just as glowing points scattered across the velvet sky, but as puzzles, quiet riddles waiting to be solved. You remember what you heard, that no telescope, no matter how vast, can easily show you a planet circling another star. The light of the star is too bright, the planet too dim, the distance too great. It would be like trying to see a firefly next to a lighthouse from 1,000 miles away. And yet we find them. We find them not by sight, but by story. By reading the light as if it were a language. By watching what it does. And what it doesn't do, you learn the first method is transit. A gentle name for a quiet eclipse. A planet passes in front of its star just briefly, casting a shadow not on the ground but on your instruments. A soft, rhythmic dip in brightness. 1% less light. Maybe even less. It's like a blink you almost miss. But when it happens again, okay, and again, like a breath, like a heartbeat, you know something is there. You've never seen the planet itself, but you've seen the effect it has. And that is enough. Some planets orbit quickly, days, not years. Their transits come often, their patterns clear. Others take longer, and we must wait patiently. The cosmos doesn't rush, speaks in intervals and returns. You imagine that moment, a telescope. Thousands of miles from you, somewhere high and dry above the clouds, receives a drop in starlight. Just a flicker, a whisper in the beam. And somewhere a scientist notices. The numbers arrive. The star's brightness curves downward, then rises. A graph begins to form the signature of a world, and so it begins, asterisk. But not every planet aligns so perfectly with our line of sight. Most do not. So we have other ways, indirect, subtle, and powerful. You learn about the wobble. Stars, though massive, are not still. They dance, ever so slightly, tugged by the gravity of their planets. A planet pulls on its star as it orbits, like a child pulling on a parent's hand. The star responds with a sway, tiny, rhythmic, back and forth. Astronomers call it radial velocity. If you think of it more poetically, like watching a candle flame tremble from across a room. Not because of what you see directly, but because of how the light wavers as a star wobbles. Its light stretches and compresses. Toward us, the waves of light are squeezed, a blue shift. Away from us, they stretch a red shift. By measuring this pattern again and again, scientists detect the presence of something unseen. The math is delicate, but it doesn't lie. Each wobble tells you the mass of the planet. Each pulse hints at its speed, its orbit, its distance. Asterisk, and so without ever seeing it. You begin to know it. There are other methods too, like gravitational microlensing. A star passes in front of another star, and its gravity bends the light just slightly. It creates a lens, a magnifying curve in space itself. If a planet orbits the foreground star, its presence will distort the light even further. A brief surge, a spike, like the flare of a match. This happens rarely by chance. You cannot plan for it. But when it happens, it offers clues. Clues not only to the presence of a planet, but to its size and orbit. Then there's direct imaging, not common, but growing. Astronomers build massive telescopes with coronagraphs, instruments that block the star's light like a thumb before the sun. They squint into the silence, hoping to catch the faint glow of a planet beside its star. These images are blurry, ghost-like, but real. Distant suns with faint companions, each a world in its own right. Some scientists use astrometry, a method so delicate it's like measuring the width of a human hair from hundreds of miles away. It tracks the position of stars with unimaginable precision, mapping how they shift ever so slightly in the sky. Due to orbiting planets, you begin to understand the universe hides nothing completely. Everything has a ripple, a signature, a whisper. If you listen long enough with patience, with precision, the secrets start to speak. And beyond methods, there is light itself. Every beam of light carries the memory of its origin. A spectrum colors spread like a ribbon. Within that spectrum are lines, tiny gaps, tiny imprints. They tell you which elements the star contains. And if a planet passes in front, some of that starlight filters through the planet's atmosphere. The result? A new spectrum, one that holds the fingerprints of the planet's air, hydrogen, oxygen, methane, water vapor. Each one leaves its trace. And so, through nothing but light, you begin to read the recipe of distant skies. You marvel at this, how invisible becomes visible, how silence becomes signal. You think of astronomers, not just as scientists, but as translators turning faint pulses of starlight into descriptions of entire worlds. And the precision matters. A planet's size, its orbit, its temperature, all can be inferred from these measurements. It's enough to guess whether it might have oceans or clouds, or perhaps life. You see the science as a kind of poetry, a partnership between certainty and imagination. The data gives shape and the mind gives meaning. Each new planet found is a new question asked, not a conclusion, but a beginning. You feel it in your chest, the swell of wonder, slow and soft like a tide. It is not the rush of discovery, but the quiet of it. The serenity that comes with knowing the universe is rich and layered and not beyond reach. We have not yet touched these worlds. We have not walked their soil or tasted their air, but we know they are there because of the shadows, the wobbles, the flickers, the fingerprints in the light. The methods are many and growing. The telescopes become stronger. The algorithms more refined. The dreams more precise, and the sky, it waits, full of worlds still hidden, still whispering. But among those whispers, one question rises more than all the rest. How would we know if life is truly there? If we cannot visit, can we listen for breath, for chemistry, for signs in the glow? You close your eyes. What would it sound like if a planet were alive? But among those whispers, one question rises more than all the rest. How would we know if life is truly there? What would it sound like if a planet were alive? Asterisk. The stars do not speak, and yet they tell stories. You listen now not for movement, not for mass, but for air. It's the invisible cloak that wraps a planet, its atmosphere. Thin, fragile, glowing slightly in the star's light. It carries the signatures of whatever breathes, burns, or breaks within. You. Floats in thought, hovering gently above a planet far from Earth. You cannot see it clearly. It is too distant. It's too shrouded, but you know it is there. And you wonder, what does it exhale? Every planet has a chemistry. Some are sterile, their skies heavy with carbon dioxide and nothing more. Some are blanketed in thick hydrogen, others cloaked in clouds of ammonia or sulfuric acid. Some shimmer in the cold silence with methane haze. Others pulse with storms or shimmer in reflection. But a few atmospheres carry something stranger. Not just gas, but pattern, imbalance, tension, a whisper of disequilibrium. And that is where your journey leads. You learn to read light differently, not as brightness, but as spectrum. Starlight splits when passed through a prism or an atmosphere like threads pulled from a single beam. These threads contain lines, absorption lines, gaps, that tell you what molecules were present. Oxygen absorbs light in a different way than methane. Water vapor leaves a different trace. Then ozone. These lines, these shadows in the rainbow, are the fingerprints of life, or at least of chemistry that life could use. It's like reading a diary written in sunlight. But it is not just the presence of a gas, it's the presence of contrast. Life, you discover, creates imbalance. On Earth, oxygen fills our sky, but only because of living things. Plants, algae, forests, and seas. Without them, oxygen would fade. It is too reactive, too eager to combine. Its presence means something is replenishing it. Constantly methane too tells a tale. On Earth, it seeps from bacteria, from decay, from life below the surface. And yet it vanishes quickly in oxygen-rich air burned away by light. So what happens when you see both oxygen and methane floating together in a planet's atmosphere? It means something odd, something interesting, something untweed, something active. You begin to search not for a gas, but for a tension. A push and pull that doesn't settle. Because that's what life does. It stirs, it disrupts, it breathes. Astronomers build new instruments for this task. Space telescopes like the James Webb peer deeper into spectra, beyond what the human eye could ever resolve. They isolate wavelengths, measure depth and brightness, compare patterns across time. Asterisk and through those numbers, through that dance of curves and lines, they begin to glimpse atmospheres. The first confirmed exoplanet atmospheres came from Jupiter's massive gas giants orbiting close to their stars. Not hospitable, not home. But their size made their signals easier to detect. Water vapor was found first, then sodium, then carbon compounds. These were triumphs not because they promised life, but because they proved it was possible to read these signals at all. Now, the tools grow sharper. Scientists turn their gaze towards smaller planets, super-Earths, minitunes, Earth-sized. Worlds in the habitable zones of red dwarfs. These are harder, fainter. The light more scattered, the signals thinner. But they are there. And sometimes there is something unusual in the air. You imagine standing on one of those worlds? The sky might be purple or green or gold. The clouds might be thick or scattered. The sun might be red and low, or white and fierce. You breathe in, and the air tells you what has been living there, or what still is. Perhaps not all life breathes oxygen. Perhaps not all life needs water. But here now, you are searching for what you know, for signatures that Earth life would leave behind because it's all we've learned to look for. And so, scientists search for biosignatures, ozone layers, methane cycles, nitrous oxide, combinations that suggest not just chemistry, but metabolism. Not just geology, but biology, and they must be careful. Volcanoes can produce methane. Lightning can form nitrogen compounds. Planets can surprise us with chemistry that mimics life, but isn't. So it's not just about finding a gas. It's about finding context, patterns, repeatability, layer upon layer of evidence that builds a case for something more. And still, we are cautious. The universe is not obliged to be simple. But then, what if? What if one day a planet distant and dim shows a spectrum unlike any we've seen? Oxygen, yes, but with methane, with ozone, with other gases and ratios that don't make sense without something living, breathing, cycling. You Picture the moment the signal arrives. The data is clean. It repeats. It holds steady. And in that silence, a new possibility is born. Not proof, but wonder. Astronomers do not shout. They whisper. They confirm. They test and retest. But deep inside, a flame flickers. A thought. This one might be alive. And with that, the world begins to change. Not because we found aliens, but because we found air that might hold a story. Some ask, why is atmosphere so important? You answer, because it is the medium of life's breath. Because it is where gases mix, where sunlight meets matter. Where the signs are too faint to be seen but too loud to ignore. Asterisk, even on Earth, the air holds memory. It tells of our forests, our industries, our creatures. It carries our warmth, our storms, our breath on another world. It might do the same, and if we learn to read it, truly read it, we may one day find that we are not the only ones with a sky full of whispers. You drift with that thought. That life might not scream across space, but simply exhale. And somewhere, light catches that breath, scatters it across time, and delivers it to us not as a voice, not as a message, but as a pattern in the light, a rhythm in the glow. A question sent across the stars. Can you hear me? Listen. Asterisk. And then you ask yourself, before you can know what is out there, do you truly know what made life possible here? What balance allowed Earth's sky to bloom with breath? Okay? And could that balance, fragile, elegant, be the secret key to finding life again? And then you ask yourself, before you can know what is out there, do you truly know what made life possible here? What balance allowed Earth's sky to bloom with breath? And could that balance, fragile, elegant, be the secret key to finding life again? Finding life again? You stand on familiar ground, and yet you begin to see it differently. The soil beneath your feet. The sky above. The soft curl of air against your cheek. These are not givens. They are gifts. The earth you know, the world you call home, is not inevitable. It is rare. It is tuned. And so you ask, what made life here not just possible, but persistent? To answer that, you slow down. You look not outward, but inward. Not at the stars, but at the soil, the air, the balance that makes Earth breathe. You begin with distance. Earth orbits at just the right range, from the sun, not too close, not too far. In this thin band of space, water remains liquid. Ice doesn't claim the oceans, and heat doesn't boil them away. This region has a name, the habitable zone. But here, on Earth, you simply call it home. Move the planet a little inward, and everything scorches. A little outward, and everything freezes. This narrow path, this orbital lane is your cradle. But distance alone is not enough. You look at the atmosphere, a delicate blend of nitrogen, oxygen, carbon dioxide, water vapor. Thin, but not too thin. Thick, but not too thick. It keeps the temperature steady, protects against radiation, carries clouds and storms. It breathes with the planet. Then there is gravity. It's just strong enough to hold the air, but not so strong that it crushes life. It holds oceans in place, shapes the tides. Hugs every living thing with a quiet pull. You feel that pull now, grounding, steady, always there, and beneath your feet. The core, molten, churning, generating a magnetic field that shields the planet from solar winds. Without it, the air might drift away, as it did on Mars. Without it, the surface might be stripped bare. The Earth hums with movement, tectonic plates drifting, volcanoes venting, oceans cycling heat. It is a living system, not just life upon it, but life within it. You see it in the carbon cycle, how volcanoes exhale carbon, how plants inhale it, how oceans absorb and release it. A dance, slow and unseen, that keeps the climate in balance. You trace this balance through time, through warm periods and ice ages, through extinctions and bloomings. Earth adapts. Earth recovers. Earth holds. But it's not perfect. It's not. eternal. It is and always has been fragile. You feel that fragility in the thinness of the air, just a few miles of breathable sky, in the fineness of temperature ranges, a few degrees tipping between abundance and drought, in the cycles of rain, wind, and sun that could so easily unravel. And yet, here you are, because of water, because of atmosphere, because of magnetic fields, plate tectonics, a large moon that steadies the tilt, a sun that shines stable light, because of luck and balance. You realize that Earth is not just a planet. It is a template. If we are to search for another Earth, we must first understand this one deeply. Not just its elements, but their harmony, the symphony of conditions that make life possible. When scientists model habitability, they start here. They ask, what would be needed to recreate this balance elsewhere? A rocky planet, a stable orbit, a breathable sky. Liquid water, a temperate surface, a protective field. But more than that, time. Life didn't appear instantly. It took billions of years. And it changed the planet as it grew. Photosynthesis filled the sky with oxygen. The ozone layer formed. Complex life emerged. Forests spread. Minds awakened. Life shaped Earth. Even as Earth shaped life. You look at the trees and realize they are part of the atmosphere, part of the cycle, part of the equation. Life and planet are not separate. They co-create. So what does that mean for planets out there? You begin to imagine, could another Earth be forming right now, somewhere far away, still molten, or already lush, still waiting for its first spark? Or maybe it bloomed long ago, and its version of trees or breath or thought is already painting its sky with clues. Clues we might one day read. You know now that to search for another Earth is not to find a twin, but to find a rhyme, a rhythm, a pattern that feels familiar, even if it is strange. Maybe it has two moons. Maybe its oceans are green. Maybe its gravity is heavier or its day longer. But if the balance holds, if water flows, if temperatures range gently, then atmosphere breathes, then life might rise. You realize something else too. Earth's history is not smooth. It has been. Hit by asteroids, it has frozen over. It has erupted and cracked and quaked. And still, it persisted. So perhaps the perfect planet isn't the quietest one, but the one that can bend without breaking. You feel a quiet admiration. Now for the home beneath your feet. It has endured. It has balanced on the edge of chaos. And yet it has flourished. You see its reflection in the sky, not as a rarity, but as a possibility. To find another Earth, you must look for places where balance might exist, not forever, but long enough for life to rise, long enough for breath to change the air, long enough for light to carry the news across space. And so you look back at the stars and ask, where else might the conditions be? Just right. And so you look back at the stars and ask, where else might the conditions be? Just right. Asterisk, you float now, beyond Earth, beyond home, into the quiet space between stars. Here, everything depends on distance. A star burns at its center, brilliant and fierce, its light spilling outward in all directions. The space around it is a gradient heat, fading into cold, brightness falling into shadow. The further you drift, the colder it becomes. The closer you approach, the more the light begins to sear, and somewhere in this stretch of space there lies a narrow zone. Not too hot, not too cold, a temperate ribbon, thin, fragile, changing with the nature of the star. This is the habitable zone. It's not a place with borders, not a glowing band you can see. It is a thermal possibility, a range of distance where liquid water, that strange and essential molecule, can exist on a planet's surface. Water, the softest of substances. The shapeshifter ice when too cold, vapor when too hot. But in between, it flows. And where it flows, life may begin. You imagine this zone not as a place, but as a pause, a space where extremes slow, where elements linger long enough, To bind, to build, to breathe. In fairy tales, it's the Goldilocks zone. Not too hot, not too cold, but just right. But what is just right depends on the star. 4 stars larger and hotter than our sun. The zone lies farther outstretched. Wide but fleeting because those stars live fast and die young. Their brightness doesn't last long enough for life to settle in. For red dwarfs, the smallest, dimmest stars, the zone creeps in close, almost hugging the star. These stars are cool and slow-burning, living trillions of years. Their planets may have time, but they face new challenges: radiation flares, tidal locking, thin zones of comfort. You begin to see the habitable zone not as a guarantee, but as an invitation. A chance, and chance, in a universe this large means possibility. Scientists now search for planets that lie in this narrow band. Not too scorched, not too frozen. Close enough to their stars to be warm, but not so close that their oceans would steam away. But there's more to it than distance. A planet's atmosphere plays a role, trapping warmth, reflecting light. A thick atmosphere might extend the zone outward. A thin one might shrink it. Volcanic activity, rotation, cloud cover, all these subtle details shape whether water can stay in its liquid form. You realize how delicate it all is. A few degrees shift, and oceans freeze or vanish. It's a slight change in orbit, and seasons grow. Too wild or too still. Too much greenhouse gas, and the planet chokes. It's too little, and it falls asleep. It's not just about being in the zone. It's about staying there. Earth has done this for billions of years. Somehow, by luck or balance or both, it has remained within the comfort range, adjusting, adapting, holding steady through all its changes. Other planets have not been so fortunate. Mars, once warmer, lost its atmosphere and froze. Venus, likely. Once wet, grew too hot and suffocated beneath clouds of acid. They sit near the zone, maybe even in it, but the conditions were not right or not long enough. So the habitable zone is not a promise, is a possibility waiting to be shaped by a planet's story. And when we look to exoplanets, those distant, shadowed worlds, we search first for this quiet lane of thermal grace. We modeled their orbits, study their stars, estimate how much energy they receive. We ask, could water exist there? Could it stay long enough for molecules to become cells, for cells to become ecosystems? And the answer, sometimes, is yes. Dozens of Earth-sized planets now float within habitable zones around distant stars. Some are close, some are far. Some circle red dwarfs, some suns like ours. We cannot say they are Earths. We cannot say they live. But we can say they might. And in a universe this large, might is everything. You picture them now, floating quietly in their gentle orbits. Their days passing in rhythms we cannot yet imagine. A planet where the rain falls slowly. Under a deep crimson sky, another where clouds of methane drift through golden light. Another where oceans stretch across the surface unbroken, still untouched by life, but waiting for the spark. Waiting for warmth to last. Waiting for molecules to stir and wake. Even on Earth, life began in warmth and water. Not in fire or ice, in puddles, in seas. In that temperate pause, and so we search for that same pause elsewhere. The habitable zone becomes a map, not just of temperature, but of hope. We send missions to find these worlds. We build instruments too, detect their atmospheres. We model their climates, wonder if they spin, if they tilt, if they bloom, We imagine explorers far in the future approaching one of these worlds, their ships slowing, their sensors humming. The first glimpse, blue or green or white. The first signs, clouds, continents, shimmer. And the first landing, breath held. Footfall, soft air tasted. But long before that day, it begins here with a number, a range, a line drawn around a star, faint and theoretical. The place where warmth lingers, where water might wait, where life, if given the chance, might rise. You return again to the stars. Not all zones are habitable, but some are. Not all worlds are ready, but some might be. Not all questions have answers, but some are worth asking. And now you wonder what kinds of surfaces wait within those quiet, balanced zones. Is there fire, ice, ocean? Where does the world touch its own skin? And what secrets lie beneath? And now you wonder, what kinds of surfaces wait within those quiet, balanced zones? Is there fire, ice, ocean? Where does the world touch its own skin? And what secrets lie beneath? Asterisk, you drift now toward the worlds themselves, toward their skin. Their surfaces, their raw and waiting forms, each planet you pass feels like a closed book, a cover without words. You cannot see what lies beneath the clouds, but you begin to imagine. You picture alien terrains shaped by time and temperature, by gravity and pressure, by silence and storm. Surfaces are more than scenery. They are stories. They tell of formation, of survival, of what a planet has endured, what it might become. You begin with fire. There are worlds that burn, scorched by their stars, their faces always turned toward heat. On these planets, the day side blazes, while the night side freezes, locked in a gravitational embrace. Lava pulses through fissures. Rock melts into rivers. Rain never falls. Wind may howl between extremes, but life, if it exists, must hide deep beneath, or long since have fled. These are lava worlds, molten, gleaming, hostile, yet beautiful in their violence. Some exoplanets are even hotter than Mercury. Their skies full of vaporized metals, their surfaces hot enough to glow. It rains iron, it storms with glass. Winds scream at thousands of kilometers per hour. You marvel at them, not for comfort, but for contrast. Because where there is fire, there is energy. And energy can drive change. Now you turn to ice, farther. From the warmth of stars, you find frozen planets, worlds where oceans are sealed beneath miles of ice, where the surface is still and silent. But beneath the stillness, there may be motion. On moons like Europa and Enceladus in our own solar system, thick ice hides subsurface seas. Warmed by tidal forces, they stir beneath. You wonder, could such places exist around distant stars? Could. An exoplanet wrapped in white, buried in cold, still hold a warm ocean deep within. Not all oceans live beneath sunlight, and in that hidden sea, heat from the core may mix with salts and minerals. Hydrothermal vents may rise, spilling warmth. Just as they do on Earth, where life began in the dark. Life, it seems, does not always need light between the fire worlds and the ice shells. There are planets that balance the two. You come now to ocean planets. Imagine a world entirely covered in water. No land, no mountains, no continents. Just endless sea beneath soft clouds and shifting sky. Waves stretch across horizons. Storms roll in silence. The surface reflects the sun like a liquid mirror. These aquaplanets may be common, blue orbs spinning through space. Their depth may protect warmth. Currents may carry nutrients. Their tides may rise and fall to rhythms unknown. Could life evolve in such places? Floating, drifting, feeding on light or chemistry? Perhaps entire ecosystems rise and fall without ever touching solid ground. You think of plankton here on Earth. Tiny, abundant, invisible architects of the atmosphere. Could alien oceans team with similar builders? And still, even water worlds are complex. Too much water, and the planet may drown its own geology. No volcanoes, no carbon cycle, no recycling of minerals. It's too little and life may wither. Balance, always balance. Now you drift toward super-Earth's planets larger than ours, rocky and bold. Their gravity is heavier, their skies thicker, their mountains rise taller. Some may be desert worlds with vast plains of dust. Others may host continents larger than any on Earth. Their volcanoes may be young, their tectonics still trembling. What would it feel like to stand there to feel your weight doubled? The sky unfamiliar, the air dense. Would rain fall heavier? Would sound carry farther? And what of the atmosphere? Some super-Earths may have hazy skies, dense with carbon or methane. Some may glow from within, still cooling after their birth. You wonder if their surfaces crack with quakes, or if they've settled into deep calm. You wonder if alien feet or fins, or roots, have ever touched their soils. But even with all these variations, one truth stays with you. A planet's surface does not tell the whole story. It is the interface, the place where air meets rock, where water touches light. But below it lies the heart, the molten core, the magnetic field, the engine of change, and above it, the sky, the atmosphere, the breath. Together, they form a system, a body, a potential. Even the harshest surfaces may hide gentleness. Even the strangest worlds may carry warmth. And even in the bleakest places, life may find a way. You think of extremophiles, those tiny, tenacious creatures on Earth that live in boiling springs, in frozen deserts, in acid pools and radiation. Storms, they remind you, life adapts. Life endures. Life surprises. So when you picture an alien surface, you don't ask if it's Earth-like. You ask if it can change, if it can hold warmth, if it can cycle, crack, flow, breathe. Because where there is motion, there is potential. Where there is a surface and something stirring beneath or above it, there is a chance. And so the search continues, not just for pretty planets, not just for twins, but for places that burn, freeze, flood, break, and still, perhaps, become home. You. Close your eyes and float above one such world now. Its land is dark and jagged. Its seas are green with strange algae. Its clouds pulse with slow lightning. It's back and somewhere just beneath a rocky ridge, heat rises through cracks in the crust. You do not know what lives there, but you feel something, a hint, possibility, a pattern in the rock, and from this a new question rises. What would that life, if it exists, look like? Would it be familiar or entirely beautifully alien? And from this, a new question rises. What would that life, if it exists, look like? Would it be familiar or entirely beautifully alien? Asterisk, you linger in stillness, drifting above a planet. You do not know and wonder who or what might know it from within. What does it mean to be alive? You think of the familiar cells, organs, blood, breath, eyes that see, limbs that move, thoughts that flicker behind bone. You imagine soft skin, plant roots, feathers, scales, lungs, and laughter. But this, all of this, is Earth's story. Evolution's song as it played on a single world, under a single sun. Beyond Earth, the music might be different. You begin with the building blocks. Life, as you know it, is made of carbon. Carbon bonds with ease, flexing into chains and loops, spiraling into the structures of proteins and cells. It dances with hydrogen, oxygen, nitrogen, weaving the soft machinery of life. DNA, amino acids, sugars, all rise from this dance. But is carbon the only way? Some scientists think not. They imagine life built on silicon, a cousin of carbon found in sand, in stone. Silicon doesn't bond quite as flexibly, but in the right conditions, it might form sturdy frameworks. It's a different kind of biology. Perhaps slower, more mineral, more crystalline. Could something silicon-based move? Think. Remember, you don't know, but you wonder. Then there is water, the solvent of life, the medium in which cells swim, reactions spark, molecules mix. Earth, life needs it like breath. But elsewhere, could ammonia take its place? Or methane? Could life bloom in lakes of hydrocarbons, as they do on Saturn's moon Titan? The periodic table opens like a cabinet of unknown recipes. Even Earth life has surprised us. Extremophiles live in boiling acid, in deep caves, in the hearts of glaciers. They survive radiation, vacuum, pressure. Some don't need sunlight. Some don't even need oxygen, if Earth holds such strange survivors. Imagine what other worlds might teach us, and now you try to picture them. Would alien life have eyes? Perhaps if light exists to be sensed, but perhaps not. In oceans deep beneath ice, sight may give way to feel or to sound. Echolocation, heat, magnetism. Chemical gradients, asterisk. You imagine life that pulses, that shifts color to speak, that swims through thick air or thin water, stretching long, boneless limbs. Would it be soft? Hard? Would it be singular or made of swarms? Would it grow roots into rock? Or float in gas? Or cling to cliffs? Would it age? Would it die? If you think about DNA, Earth's code, a double helix spinning in every cell. But even that may be unique to here. Asterisk on another planet, genetic material might be tripled, twisted, reversed. The language of inheritance might be unfamiliar, but still, it might rhyme, because the essence of life, perhaps, it's not the ingredients, but the pattern. Reproduction, variation, response. Asterisk, a system that builds itself, repairs itself, copies. Itself changes when the world demands it, even if we don't recognize the shape. We might feel the intent. You consider intelligence, thought, culture. Would alien life be aware? Would it build, sing, mourn? Would it have tools, or art, or story? Or would its intelligence be biological, like a fungus spreading across a continent, responding, computing, adapting? Would it speak through pulses of light, through vibrations? In roots, would it be collective? Would it dream? You don't know. You don't need to, because the lesson is not to guess correctly, but to imagine widely, to let go of Earth's mold, and look instead for motion, for process, for change. And perhaps in that widening, you come closer to understanding your own world. Because even on Earth, life is still a mystery. What makes one thing alive and another not? Where is the line between chemistry and consciousness? Imagine the first stirrings of life on a distant world. Simple molecules, clustered, bumping, reacting. A tiny cycle forms. Energy flows, materials renew, a border grows. A cell, then two. Then more, not life as we know it, but life all the same. You return to the idea of the alien. Not monstrous, but marvelous. Not threatening, but thrilling. Not entirely foreign, but oddly familiar. Because life, if it exists out there, must face the same questions we do. How to grow, how to adapt, how to survive. What changes, and in that shared question, even across impossible distances, you feel kinship. You wonder now, if we found life, how would we? No, would it be chemical, spectral? Would it be a movement in the soil, a signal in the sky? Would we understand it immediately, or spend lifetimes decoding? Would it understand us? Or would we simply look at one another, life to life, and feel that same quiet awe? You drift in that thought of discovery not as proof, but as connection. And you realize softly that alien life might not look like us, but it might feel like us. It might want and learn and adjust. It might grow toward light or warmth or possibility. Just as we do. You open your mind to the strangeness of it, not to fear it, but to welcome it, because somewhere, perhaps, in a sea of methane or a cave of crystal, something stirs now, not knowing we exist, and one day, perhaps, we will meet not in person, but in understanding, through a spectrum, through a rhythm, through a fingerprint in the air, and when we do, the most surprising thing might not be how different it is, but how alive it is. And now, as that idea rests quietly in your thoughts, another question begins to form. What about the planets that shouldn't exist? The ones that defy the rules, that seem to break the logic of how planets form and behave. Could they be the strangest of all? And now, as that idea rests quietly in your thoughts, another question begins to form. What about the planets that shouldn't exist? The ones that defy the rules, that seem to break the logic of how planets form and behave. Could they be the strangest of all? Asterisk. The cosmos is vast, and sometimes it surprises even itself. You've learned the patterns. Stars form from gas. Planets spin from dust. Orbits fall into balance. You've felt the elegance of gravity shaping rings, of temperature carving zones. There is order in the stars, a rhythm in the way things form. But every so often, something doesn't fit. And In those moments, science pauses, tilts its head, begins again. You drift now toward the outliers, the misfits, the planets that shouldn't be and yet are. The first to shake the rules were the hot Jupiters, giant gas planets many times the size of Earth, more massive than Jupiter, circling their stars at scorchingly close distances. They orbit not in years, but in days. Some whip around in just 18 hours. They should not be there. According to the early models, gas giants form far from their stars, where it's cold, where hydrogen can cling, where cores grow slowly. Yet here were these burning giants, hugging. Their suns, how? Perhaps they formed far out and migrated inward. Perhaps they were pulled, thrown, nudged by gravitational dances with siblings. Or maybe we still don't fully understand. They are strange. Our atmospheres are puffed, their clouds laced with metals. Some glow from internal heat, their skies darker than ash. They do not resemble home. But they are real. Then there are rogue planets, loners, drifters, orphans. They do not orbit any star. They wander freely through space, untethered, unseen, unless they pass in front of something else. How did they get there? Some were likely ejected, flung by gravity during chaotic early formation. Others may have formed in isolation from clumps of gas that never became stars. They are cold, dark, silent, and yet they may have cores, atmospheres, moons. They may hold warmth deep within from slow radioactive decay, and that warmth might be enough. Imagine a world adrift, lit only by its own faint breath of heat. An underground ocean, a crust of frozen stone, and within something moving, something small. Not all life needs a sun. Now you pass a diamond world, a planet so rich in carbon and heat, it has compressed part of itself into crystal. Its mountains glitter, its crust sparkles. It is heavy, bright, impossible seeming, and yet its physics checks out. Carbon under pressure becomes diamond. Its presence suggests something wondrous. A star once rich in carbon gave rise to this shimmering planet. It spins now in silence, jewel in the dark. You visit Superpuff's giant planets as large as Jupiter, but as light as cotton candy. Their gravity is weak. Their atmospheres balloon outward. They shouldn't be able to hold together, and yet they do. They float like ghost worlds, their clouds drifting far above their cores. You explore ultra-short period. Planets, worlds that skim their stars, completing orbits in hours. Some are so close they are being eaten, their atmospheres stripped, leaving comet-like tails behind them. They blaze and erode. And endure. You find planets that orbit two suns, like dancers pulled by two centers. Their light shifts from gold. Two red, two silver. Their shadows multiply. Their climates twist. They shouldn't be stable. And yet they are. You find planets older than logic allows, minus 11 or 12 billion years old. Formed in a universe still young, their stars long since cooled. Their orbits still calm? Asterisk, they raise a strange question. Could life have begun long before Earth? You see now that the universe is not made of rules, it's made of exceptions. Rules are what we build from what? We see exceptions are what the universe offers when it's time to learn more. Each of these strange planets holds a clue. They don't break the laws of physics, they reveal deeper layers we hadn't yet explored. And in that way, the weirdest worlds become the most important. Because they teach us not to assume. They remind us that we are young, and the cosmos, infinitely more clever than we expect. You pause above a planet that seems to pulse, not with light, but with mystery. It defies category. Too dense, too far. Orbiting, wrong. Atmosphere, unreadable. It flickers with something not yet explained. You don't need an answer. Not yet. You simply feel the invitation. Wonder more. Assume less. These impossible planets show us that Earth is not a rulebook, only a reference. And maybe the places that shouldn't exist are the best places to look for something new. Because if life arose somewhere unexpected, if something stirred in the dark, Far from heat, far from rules, it would change everything. And now, gently, you ask yourself, even if we found a world with life, could we ever reach it? Could we cross the gulf? And now, gently, you ask yourself, even if we found a world with life, could we ever reach it? Could we cross the gulf? You lie still beneath the weight of the stars, thinking not of what might be out there, but how you might reach it, because the universe is not just beautiful, it is big. Distances stretch farther than mind or map. Even the closest star, Proxima Centauri, is over 4 light years away. Okay? And a light year is not a time, it's a distance. Roughly 9.5 trillion kilometers. A number too large to carry in your pocket. If Earth were the size of a marble, that star would still be thousands of kilometers away. Even light, swiftest thing we know, takes years to travel that far. And so you begin with this truth. Visiting another star system is one of the hardest things we can imagine, but imagining is where it starts. You float now through possibilities. The first is speed. Our current spacecraft, even the fastest probes, crawl at a cosmic pace. Voyager 1, launched in 1977, is only now just leaving the outer reaches of our solar system. At that rate, it would take tens of thousands of years to reach the nearest star. You feel the weight of time, the silence of slowness. But speed is not the only path. What if you made the ship smaller? What if instead of sending people, you sent machines? Tiny featherweight probes the size of a grain of rice, equipped with sensors, cameras, and a sail. Now imagine shining a powerful laser at that sail, pushing it with pure light. This is not fantasy. It is the concept behind Breakthrough Starshot, a real project proposing to send microprobes to Alpha Centauri at 20% the speed of light. Arrival in just over 20 years. The ship would not slow down. It would pass by in a flash. But in that flash, it could send data home. A glimpse, a whisper. A new kind of voyage. You think now of light sails, thin, reflective sheets that catch photons using sunlight or lasers to accelerate silently. No fuel. Just light sailing across space. You feel how poetic that is, ancient and futuristic all at once. But what if we wanted to go ourselves? Go ourselves. You consider generational ships, vast vessels, like slow-moving arcs, where entire communities live, grow, and pass on knowledge as they drift for centuries. Life aboard would feel like life on Earth, with gardens, gravity, stories passed down. But no one would live to see the destination. Only their descendants would arrive. Would you choose that life? To begin a journey you could not finish, but believe in enough to start. There's something gentle in that idea, a kind of cosmic trust. You explore hibernation, putting humans into deep sleep for long voyages, slowing metabolism, protecting the body through silence and time. It has not yet been done, but many creatures on Earth already do it. Bears, frogs, seeds buried in ice for decades. Could we learn from them? And then you wonder, what if we didn't go all the way but just sent our minds? Digital consciousness, uploading thought, memory, awareness into a machine. A synthetic traveler. No hunger, no age. Just a whisper of you, wrapped in code, crossing the stars. Would that still be you? You pause here, because the question is not just technical, it is emotional. What do we mean when we say we? Is it the body, the brain, the experience? Maybe to go so far, we must first decide what part of ourselves we're willing to send. And then there's time itself. Could we bend it? Could we use wormholes, shortcuts in space-time to fold the distance? Physics allows the idea, but we don't yet know how. Could we warp space? Could we curve it around us? The math whispers maybe. The engineering shouts not yet. Still you imagine it, a ship that doesn't move through space, but moves space around it. A ripple, a fold, a jump. And still another possibility. Maybe we don't go at all. Maybe we wait. Maybe we learn to send messages faster. Maybe we evolve better telescopes, more sensitive sensors. Maybe we build virtual worlds and visit distant planets through simulation fed by data, guided by math. Maybe we create understanding without ever stepping foot there. And maybe one day the universe comes to us, a signal, a visitor, a silent hello. Because if we're dreaming of them, maybe they're dreaming of us still. Something in you stirs the old longing to step forward, to touch, to see with your own eyes, to cross the gulf. Not just in mind, but in being. You think of the explorers who first crossed oceans, not knowing if land lay ahead. Of spacecraft that left Earth without a promise of return. Of the quiet courage that says, go anyway. Because sometimes, just asking how is a seed that grows into plans and ships. And sails of light. You float now at the edge of thought. Gazing across the interstellar dark dot, it seems impossible. And yet, so much once did. Air travel, satellites, landing on the moon. Each. Once just a sketch in the mind. You don't need to know the full answer now. It is enough to hold the question. Could we ever get there? Maybe one day, maybe not for you, maybe not for your children. But maybe for the ones who dream your dreams and carry them forward. And maybe when they arrive, they'll look back at Earth and wonder, what was it in us that reached across the stars? And maybe when they arrive, they'll look back at Earth and wonder, what was it in us that reached across the stars? Asterisk, you have traveled far now, not in distance but in thought, across chapters of sky, through equations and metaphors, through surfaces of fire and silence, through questions that have no clear answer. And here, it's at the edge of imagining, something quiet dawns within you. This journey was never only about the stars, it was also about you. Because every time we search the sky, we're also searching ourselves, you. Look up again into the dark, and this time it feels softer, less distant, more like a mirror than a mystery. What we see out there reflects who we are here. A telescope is not just a lens. It's a desire shaped into glass and orbit. Spectrograph is not just an instrument. It's a question refracted into color. And every exoplanet discovered, every flicker in starlight, every whisper of atmosphere is not just a world. It's a reflection of our hope, our science, our restlessness. Do think of the ancient ones, those who first looked up and wondered if the stars were holes in a great dome. They didn't know about galaxies, but they knew something. Essential, the sky stirs the soul, it still does. We look out there because we need to, because there's something inside us that wants to connect, to expand. To understand where we are and why, you drift now through the cosmos not as a tourist, but as a participant. You are not separate from the stars. You are their product. The calcium in your bones, the iron in your blood. It's the carbon that forms your thoughts, all forged in long-dead stars. You are made of the very dust you study. And so, when you wonder about alien life, or planetary oceans, or golden clouds on gas giants, you are also wondering about yourself. What does it mean to be alive? What does it mean to belong? What does it mean to look up and feel wonder? The universe does not answer in words. It answers in light, in orbits, in the gentle certainty of gravity, in the discovery of a planet that shouldn't exist and yet does, in the realization that water, warmth, and time might not be rare after all, and in the small, persistent feeling, almost a whisper, that you are not alone, not just in the sense of other life, but in the sense that you, as a being capable of wondering, are part of something immense, something ongoing, a conversation written. In Stardust, every discovery adds a page. Every question turns one. Even silence is part of the message. You lie still now, wrapped in this gentle enormity. You think of the data streaming down from satellites, silent, clean, coated in light. You think of students poring over graphs, of scientists in dark control rooms watching for the next flicker in the sky. You think of artists painting what they cannot see, of children pointing at stars, of lullabies sung under distant moons. We don't yet know what's out there, but we know that the sky contains more than vacuum. It contains meaning, not in the stars themselves, but in the way we search for them, in the way we ask and imagine. And build. The cosmos becomes a mirror, and in it, we see both the enormity of what is and the delicate curve of our own curiosity. You return again to Earth, not with answers, but with peace. You see it now not as a small world, but as a beginning, a cradle of thought, a whisper of life, a vantage point. And as you drift into sleep, you hold one last question gently in your breath. If the stars reflect us, what might we reflect back to the stars? And as you drift into sleep, you hold one last question gently in your breath. If the stars reflect us, what might we reflect back to the stars? Stars.